bit easier to see what we're doing. Okay, so we're doing long division, and many times does 23 fit into 4? It doesn't. So many times 23 fit into 45? Once. Okay.
22.
So there's a remainder of 22. Now there's a system here. If I do 1 times 23 and write it underneath and do that subtraction, like write it down. Does that make sense? And have you done this before? And you carry this?
Yeah, I think that's 6. Yeah.
Okay.
I didn't know. Yeah, but I
Yeah.
never knew how to do long division.
Okay, you carry the...
I just put the numbers like in the box.
Yeah.
Okay, there's multiple ways. I'm doing it this way very specifically because this is the way I'm going to divide polynomials. Okay, so I think 2, 2, 3, many times 23 fits into 2, 2, 3. 9 times because 10 is going to be 230. So 9 goes here. What goes here? 207, so 23 less than 230 would be. And I change the sign and subtract, and add the next bit on. So what I'm trying to get is the remainder. So it fits in, doesn't fit in evenly. How much am I left over here? 16 left over. I don't divide, 23 is not going to 16. I'm going to carry this and I'm going to divide it into 166 because that's 60. You could write it here like that, and that's 166 if you want. Yeah, you can do that too. But this is another way of doing it. It gives you more space. Okay? Now bear that in mind when we go to divide polynomials. We're going to divide 2 polynomials now. Let's look at... No, I could do... I know. I've left it unanswered. I'm going to do the bottom one first. X minus 3 divided into 2x squared minus x squared minus 13x cubed. Thank you. Okay, so I'm going to do this using the exact same method. Right. Yeah, so I'm going to think right. I want to figure out how many times this is going to fit into this, but I can't do it all at once. If I did it all at once, then I just have the answer. So I'm going to do it bit by bit. I know that this would multiply by something to give 2x cubed. The first thing is 2x squared. Why 2x squared? Because this times this will give 2x, a bit like with the thing we did yesterday. When you had to... I haven't finished. Okay, so that 2x squared is going to end up being multiplied by both these. So I'm going to say, right, let's do that. 2x cubed. And this times this minus 6x squared. So it's the same as when I did 1 times 23. I did 1 times 23 and I wrote it down here. So I'm doing 2x times this, the divisor. Write it down here. What am I going to do next? Well, what did I do here? I subtracted that to find my remainder. So I'm going to subtract this, which subtracts this, but actually adds this.
Why?
Because minus minus is a plus. So this was a minus 6 and now is a plus 6. I can write it like that either. So that's gone, which is what I want. So a bit of it cancelled out. What's my remainder? 5x squared. Because that negative became a positive, and this is a negative x squared. I combined those two. Yes, combine the two. So it's like I brought it, and now I'm going to bring this down. This is... So the x cubed is part of this one, x squared is part of this one, and then I bring this next thing down, a bit like I brought this 6 down. So how many times does this fit into this then is my next thought. So into 5x squared, are we happy with plus 5x? This fits into this. I'm just looking at this in the first term. The 3 is kind of my afterthought. So this... Then, if I multiply by both of these, I get the term to subtract here and find my remainder. Same as this, I multiplied by the 9 next, and then I subtracted to get the remainder. Why is that a question? Minus 15x. Think about your question before you ask it. So I've got this. What do I do next?
2x.
I subtract them. So I subtract. So remember to do that. Often the signs can be a bit tricky. So that's minus, and this one becomes a plus. Whatever way you want to show that the plus is the one that's winning, I usually literally just change the sign so I don't have to worry about it. This goes away, which is what I wanted. That should... And 2x is left over here. What's next, the minus 6. Now, what you're hoping for, in this case it does work out, is that this whole thing would fit perfectly into this. But it doesn't always. So what goes here? 2. So then I do 2 times both these. 2 times x gives 2x. 2 times 3 gives minus 6. Subtract those from each other. I'm ending up with a remainder of 0, so it fits in perfectly. The other question now I'm going to do does not fit in perfectly, and we figure out what we do in that case.
Wait, I don't understand how you got the 2 from. I see that it's just x minus 3 fits into 2x minus 6 twice. That's it.
That's it. Yeah. So the 2, I look at this first term. I'm always just looking at the first term and dividing by, not the second. Yeah. Yes. Yeah. You will only look at the first term in this particular case, because we only deal with the last term and the very last. It's like when you're dealing with the when that question we had yesterday, and there was the 3 and the 1 have to multiply to give only the last bit of it. This thing we can figure out by getting the last. Just look at the last digit. Okay, maybe that didn't answer it very well. I'll get rid of this one. I'll keep the other one. I'm going to do the second example. I'll do it in a different color. It's a more difficult example. I don't know. Is it filming? Yeah. Okay. Okay, I'm going to do this one next. The first thing I notice here is there's no x cubed term and there's no x term in the numerator.
It's going to cancel out.
Somehow it might cancel out. But does that mean there won't be one in the answer?
It's going to be imaginary number?
No, it won't be imaginary numbers. Well, we kind of know it will be in the answer, don't we? Because x4 divided by the x is going to probably create an x3. So that means there could be a remainder with x3 in it somewhere in there. But they just canceled out. So when I go to write this division down, x plus 3, I'm going to divide into x plus 4. What am I going to write next? Plus 0x cubed. I'm going to fill in any gaps that are in the polynomial with a possibility that there is a term here.
Well, why don't you fill in? Yeah.
Sorry, we know there's not, but that also means that the coefficient of x would equal 0, and the coefficient of x cubed would equal 0.
Wait, why don't we know there's not? 2x squared divided by x.
Yeah, we'll get to that, but we know that there is some gaps here in the function. The function is almost not complete. Yeah. But maybe when you divide an x4 by an x, you get an x cubed. So there's probably going to be an x cubed in the answer, which means it's probably going to be a remainder of some sort of x cubed as well. Okay, let's look at our system again. What do? We kind of ignore the 3 for now. We just focus on this first term and this first term and see how many they fit in. So x cubed, you think what number multiplied by x gives x4? X cubed. What's my next step? Cubed by both of these creates this position. So I have x4 plus 3x cubed. Draw a line underneath like I'm doing long division. I'll get rid of that. Then I change the sign, I subtract, like I want to find the remainder. Yes?
You said you do. Oh, never mind.
Okay. So I subtract. Minus, minus. That gone. Minus 3x cubed here. Yes?
Yeah.
What do I do next? This comes down.
Not the 0x cubed?
No, that's already been combined with this one. 0x cubed, take away 3x cubed is, yeah, it's already in there. All right, so what's next? This is my new line I need to look at. Yeah, how many times, what multiplied by x multiplied by something gives this answer? What? Negative 3x squared. Negative 3x squared times x gives this. And that's where we start the next line. This has got to be multiplied by both these and written here. Minus 3x cubed minus 9x squared. This times this one. Draw a line. change the sign. They're both plus now. So I'm subtracting here, but it looks like adding because they were both negative. And I get 11x squared. Next step, bring down the 0. I restart, plus 0x. Because there's going to be some remainder with an x.
Wait, who found this out? I'm sorry.
It is just long division. It's just long division. The same.
How did someone figure this out?
I think you probably could figure this out given enough time. If I gave the whole class 6 hours to figure this out, and I said you can't get out of the room until you figure it out, you might figure it out.
But I mean, like, how was it invented? Like, this is...
By just that thing. By just that thing.
Okay.
Because you know that a linear multiplied by a quadratic gives a cubic.
That's true.
So you know that the answer to this question is a cubic equation. You don't know which one. So that might be your starting point. Okay, we're at this stage. We need to think about, okay, x, 11x. 11x times this x gives 11x squared. So this number, and this number were the ones I was dividing into. So now I take the 11x and multiply it by both these. 11x squared plus 3x. 33, yes, sorry, I didn't multiply. 33x. Subtract. This one goes...
Why you subtract it every time? It's
Yeah.
kind of redundant.
So when I did the long division, and my first thing was, I think it was 45 was the first number here, and 23 was dividing in. Fit in once, and I said, right, what's my remainder? 1 times 23, what was my remainder? Oh, 22. It's just a way of calculating the remainder. My remainder here was 22, so I put it here. And then it added on to the next figure to make the next number you divide into. We're doing that exact same process here. Okay, I have negative 33x. Uh-oh. And minus 1, yes. Pen is running out. So we're not going to get it. It's not going to fit in perfectly. We know, we kind of see that already, or maybe you don't. Because I have to put minus 33 here. Oh, oops. Minus 33 here.
Why not minus 33x?
Minus 33 times x.
Oh, you're right, sorry.
Yeah. So minus 33x goes here when I multiply. That one's gone, that one's done. But I get minus 99. I really want a minus 1 there, and so it all cancel. But it doesn't, and that's just life. So plus plus when I go to subtract, and I'm left with 98 as my remainder. Now, how do I write the answer to this question?
What is it?
X, you add minus 3x squared plus x minus 33r. Isn't that how you do it?
Yeah, okay. So when I think about changing an improper fraction into a mixed number, I go, right, what's 11 over 4? Into a mixed number. 2 and 3/4. Notice the way the...
I was expecting Ryan to shout it out.
Notice the way the divisor's still knocking around. The numerator's still knocking around in my answer because it doesn't go in fully.
Yeah.
Okay, let's write this answer. The answer to this question, x cubed minus 3x squared plus 11x minus 33, that's the equivalent of 2. That's what fitted in. What's my remainder? Plus 98 over x plus 3.
Oh, why? But it's... yeah, no. You basically did all that, and then you didn't divide it.
There is another way of writing this answer. There's just a rearrangement of this line, which might be nicer. Another way of writing, some people like to write this, like the function, and they times it by this plus 98. Do you see what I've just multiplied that up there? So you get a common denominator. You can write it like that. I prefer